Hello, welcome to my video for my mechanics proposal as far as the project. And I figured a video is best because, I don't know, I like watching videos, so, that works. So I'll go show my organization. And this shows the stuff I've plotted for my project thus far, but we're not going to look at all these because most of these are incomplete. The one we'll be looking for the proposal is just the central one, which lists my main project. So I'm going to do a visual simulation of stress-strain behavior. The end goal will be using modeling and interpretation from stress-strain data to create a simulation for deformation under uniaxial stress. This is going to be done using atlas of stress strain curves. At least that will be the source of our data, given that most stress strain curves are going to be empirical in nature. So best to get it from one source. All right, and then the second part of the goal will be to create an animated stress strain curve, which I figure will be easy given that we have the data. There'll be some 2D bar stretching. Stretching's what I have now. We might do compression. I'm not. Whichever one ends up being more convenient to model is what I'll go with, or reasonable to model in the given time frame. But I'll figure that as I go more along into the project. And then I will do these stretching visuals at different stress levels across different materials to compare. Because that's the whole point, is this is material science. I'm going to show the same couple of experiments, maybe one or two experiments across three different materials, or two or three, and my plan is to put them side by side, hopefully, like the simulations at different, so you can see the difference between how, say, aluminum or copper responds to stress. All right, and then the cleaned and curated CSV of stress strain data. I mean, that's going to be part of the other one. And then the short demo video will be how I do it. I'll do it just like this proposal. It'll be a video. So it'll cover this whole thing over here once it's actually finished, with every little bit that I kind of had to learn to do this project. But as that is not complete, I am not going to show this. So our assumptions are going to be uniaxial tension. I could do both ways, but given the shortness of this project, I don't want to overload myself at work, considering I've got finals coming up. I have engineering stress and engineering strain, which are basically just the formulas we learn in class. Basically, we're using simplified formulas. You don't want to use any crazy models, especially for that linear portion that obeys Hooke laws, more or less. We don't want to overcomplicate that part, as the plasticity portion is probably already going to be somewhat of an undertaking. And then the fourth assumption is quasi-static loading. Basically, we're not going to do any crazy shifts, right? So just a pretty, almost like a creeping assumption. Maybe that's not the right word, but it's going to be very simplified. So what I need to learn coding-wise will be basic Python. I don't think this will be too hard for me to learn, as I have some experience in other coding languages. Not much, but enough to learn the basics for this. And then the harder portion will be learning these plugins like Pandas, NumPy, SciPy, Matplotlib, to really do the experiment I want to do. Then for theory, we are going to do elasticity. This is the beginning linear portion of the stress strain curve, and that was defined in class. I think I might have to do a little more research on it just to double, kind of make sure my understanding of it's full, but it should be, my knowledge is probably already 75% there. And then I'll have to delve into a little bit of theory on understanding what's going on in the plastic deformation part of the curve so that my model doesn't come out weird. Obviously I know what's going on to create a proper model and a proper visual. And the reason I want to do this project is because material science is interesting. I like chemistry, I like material science, I like mechanics. It's cool. Wouldn't pick something that I don't like. Two, material science is super useful for any engineer. I believe this. I'm from a petroleum background, but I feel like no matter what engineering major you are, biomedical, mechanical, electrical, understanding how materials work will shift your understanding of everything. It's not even just important to making things, it's understanding what things can withstand, right? So it's not just purely a building thing. You have to understand it to understand physics as a whole, I suppose, which would make it important for engineering. And 3, it gives me a chance to develop coding skills. Basically, I've been meaning to develop coding skills for a while, and I really haven't had the time outside of my basic coding for engineers class, but I want to learn Python more than I want to learn MATLAB. So this gives me a chance to do it and put something on my resume to show that I can somewhat do it. It all works nicely, and I get a little grade boost. So it's not just a waste of my time. Well, it wouldn't be a waste of my time, but it's more like it doesn't take away from my grade in this class, sort of, to do this, to start learning Python, right? Because obviously I have to divert attention away from my classes if I start learning a coding language on top of everything. So this works as a way for me to do that without, ruining what I've got going on. And yeah, that's my proposal. So hopefully it goes good in the next month and I get this done.